All right, so here we have researchers that are interested in the relationship between cigarette smoking and lung cancer. So let's suppose that an adult male is randomly selected from a particular population. The following table shows the probabilities of some events related to this chance process. So here we have the events that they smoke, smokes and gets cancer, does not smoke, does not get cancer. The probability is 0.25, 0.08, 0.71. All right, part A. Find the probability that the individual gets cancer given that he is a smoker. Show your work. All right, so what I'm going to do is make a two-way table because that's really going to let you see all the possible events and all their corresponding probabilities. And it's probably going to help you answer, A, B, and C much more easily. So let's have a two-way table that we're going to have rows and columns. So across here, you have the events that they either they smoke or they don't smoke. So let's go on. Smoke. Doesn't smoke. Doesn't smoke. And you have, your total at the end, of course. And then across the rows, we're going to have that they have cancer, they can get cancer. And let's just say that they're cancer-free, so they're free of cancer. And then the bottom rows and have your totals across as well. All right, now let's look at what we can fill this in with. So it says that there's a 0.25 probability that they're a smoker. So then the total proportion of smokers down here is going to be 0.25. And remember, since it's a proportion, the total is going to be 1.0, because that's, 100%. Now, the probability that they smoke and gets cancer is 0.08. So we're basically looking for the intersection of smoker and getting cancer, which will be this box right here. They smoke and they get cancer, so this will be 0.08. And then 0.71 says that that's the probability they do not smoke and does not get cancer. So no smokes, no cancer. So doesn't smoke, cancer-free. So down here, that's going to be an intersection of both of those. 0.71. Now from here, we just do some, basic, elementary addition to figure out the rest. What added to 0.25 gets 1? That'll be 0.75. And then what added to 0.71 gives you 0.75? That'll be 0.04. 0.04 plus 0.08 will be 0.12. 0.12 plus 0.88 is 1.0. And then 0.08 plus what gives you 0.25? That'll be 0.17. And now you have all the probabilities of the 4 possible events. So part A, you want to find the probability that the individual gets cancer given that they're a smoker. So if they say given that they're a smoker, we care only about the smokers in this case. So for them to be a smoker, they have to be in this column. So we're only going to care about these proportions. So we want to find the probability of cancer given that they're a smoker. And so all we're going to do is then take the proportion of cancer. We're going to take 0.08, that value, and divide it by the total right here, because that represents the total proportion of smokers. So 0.08 divided by 0.25. That'll give us 0.08 divided by 0.25. And then our answer will be 0.32. So the probability of them being a smoker, or the probability that they'll get cancer given that they're a smoker is 0.32. Okay, part B, find the probability that the individual smokes or gets cancer. Or gets cancer, so 2 things. So the probability that they smoke, let's write this out, probability that they smoke, or that's, union, get cancer. We have three things that work for that. They could be this, it could be this, that smokes, and the cancer also is in here. The only one that doesn't count is this guy. So we just simply add those three values up. 0.08 plus 0.17 plus 0.04. And that'll simply be 0.29. And so that's the answer for B. All right, now part C. So this one's a little trickier. We have two adult males that are selected at random. Find the probability that at least one of the two gets cancer. Okay, so there's a couple different ways to go about this. The way I naturally do this is looking at the probabilities of what would satisfy this. So if you have two adult males, if we're saying that at least one of them gets cancer, you could have that, we're looking at, let's say the first guy gets cancer. So let's say first man has cancer. That's one thing. First man has cancer, that satisfies at least one of them. The other thing is going to be like, oh, well, what about the second man? What if the second man gets cancer? If only the second man gets cancer, that also counts. So we add that to the probability the second man gets cancer. And the third event that satisfies this is that they both get cancer. Bad news, but that would work too. So we add that to the probability of both cancer. We'll say both cancer. So we find these three probabilities and add them up, and that'll be the value that will give us the probability that at least one of them will have cancer. So let's look at one at a time. The probability that the first man has cancer, we just select them at random. The probability that the first man has cancer is, 0.12. Now, since you're selecting two, here's what you got to think. I probably should have wrote that. So what we're actually looking at the first man this will be the first man has cancer and the second man doesn't have cancer for this to happen. So the probability of the first man having cancer is 0.12. The probability of the second guy of not having cancer is 0.88. So we multiply that. So the first guy having cancer times the probability of the second guy to have cancer, plus the probability of the second guy getting cancer means that the first guy won't get cancer. So the probability that the first guy doesn't get cancer is 0.88. The probability that the second guy gets cancer is 0.12, because it's still the same because it's just 0.12. Plus the probability they both get cancer. The probability of them both getting cancer would be that you would have to multiply both 0.12 by 0.12. Because remember, you're doing two things. Remember, this is the first guy. I think that's the first guy. That's the second guy. That's the first guy in this case. That's the second guy. That's the first, and that's the second. So for this, they both got to get cancer. Since the probability of getting cancer is 0.12, you just multiply them. And from here, you just then add all these values up. We got a calculator that will do our job, to do this job for us. Okay. And you'll get 0.2256. And there you go.